Let's take a look at how atomic mass is calculated. Most of the time, we think of an average as a straight average, meaning we add all the values up and then divide by the number of values we had. Atomic mass, however, is a weighted average. That means we need to take care of what percent abundance there is, or what percent each value contributes to the average. Let's take a look at a problem and work our way through it. Carbon has two common isotopes, carbon-12 and carbon-14. Remember, the 12 and the 14 there represent the mass. So the 12 is the mass number for carbon-12. The 14 is the mass number for 14. And that represents the protons plus the neutrons in each of those atoms. If carbon-12 has an abundance of 97.3% and carbon-14 has an abundance of 2.7%, what is the atomic mass of carbon? So we're looking to find the overall weighted average, of carbon's mass. To do that, we're going to start by taking each item separately, each isotope separate. So we're going to start with carbon-12. Carbon-12 has a mass of 12 AMU, atomic mass units, and an abundance of 97.3%. So I'm going to multiply that 12 by 0.973, that's 97.3%, to find out what the contribution of carbon-12 is to my overall atomic mass. I'm going to do the same thing with carbon-14. So for my carbon-14, I'm going to say, well, my mass number is 14. I have 14 AMU for each one. And the abundance here is 2.7%, so 0.027. Together, these would add up to 1, or 100%. So I'm going to go ahead and do that math. For that, I'm going to need a calculator. Let's get out my calculator. Alright, so the first one, 12 times 0.973, that gives me, oh, I think I did that wrong. Let's try again. Clear everything out. 12 times 0.973, that's going to give me 11.676. So let's write that in. 11.6, oops, forgot my decimal, 676 AMU, atomic mass units. And for carbon-14, we have 14 times 0.027. That comes up to 0.378. 0.378 AMU. The last step we need to take is to add these all together. So I need to add this together. 6 and 8 is 14. 4, carry the 1. 7 and 7 is 14, plus 1 makes 15. Carry my 1. 6 and 3 is 9, plus 1 is 10, so 0, carry the 1. I need to put my decimal in there. 1 and 1 is 2, plus 0 still is 2, and 1 plus 0 is 1. So 12.054 AMU would be my atomic mass of carbon, were these the actual percentages. They aren't. I totally just made this up. But that's the process by which we calculate the the atomic mass or the weighted average of the mass of each isotope.